Hey everyone, today we're gonna be doing a lead code question which is find a duplicate number in an array. So we have an array which contain n plus 1 integer and that integer can go from 1 to n. So what they can have they will be starting they will be having a sequence of number from 1 to n they have 1, 2, 3, 4, 5. So if you see a number can have from 1 to 4 but 2 is coming twice in this case. So they told like okay number can go from 1 to n but the size of an array will be n plus 1. So there will be one position like which is be filling with one extra character. Maybe there will be many characters like that. Like if you say like it is going from 1 to n, but n is coming, or you can say this number 3 is coming all over the array. So they have like they told there will be exactly, or you can say at least, or you can say exact one number which will be getting repeated, and that number can have like two or more occurrences. If you see here, two, it is like having complete array as an occurrences. Also, if we say or talk about the constraint, it say like the number can have like the array can have minimum one character and it can go maximum till 10 to the power 5 numbers. Sorry, not character, numbers. And number can have like from 1 to n, the number can have value from 1 to n. So if I say like let's do in this editor or just will mark. If I say I'll take first example, the first example is like a number, or you can say an array. This is an array which is 1, 3, 4, 2 and 2. So if I see over here, we are having 2 as duplicate part. So we are just simply we gonna saying like, okay, this is an element coming twice, or this is a duplicate element. Same way, we need to find like which of all elements, or you can say if in this case it was completely 3, 3, 3. So we want to say like, okay, which of them is a duplicate element, or like coming twice, thrice, or maybe multiple times. So we'll see. So let's talk about like just we'll see like number is like it can have what elements? It can have one, two. If I say like if one number having one and maximum it can have n. So what is n? N we can say largest number in this area. So number at max can go from 1, 2, 3 and 4. If I generally say a number from starting from 1 to n. Now we'll see like okay, one is coming once, two is coming once for now, three is also coming once, and four is also coming once. But here two came already. So that's what we need to find out, like which of the numbers here are coming twice. So let's discuss the approach one. You can say just a brute force approach. So we'll talk about the approach one, which is very brute force. What we'll doing like we will be comparing. So we'll compare all elements. So what we are going to do here, we are having this array 1, 3, 2, or you can say 1, 3, 4, 2 and 2. We gonna checking like we'll see. Okay, one go and check with all element. Are you coming twice or more? So we'll see. Okay, one compare all. No, it's not coming. Three go and compare with all the element. No, it's not coming. Four go and compare with all the elements. No, it's not coming twice. Two will see. Okay, at least I get one more occurrences. So we'll say okay, two in this case is the duplicate element. So we'll return this element, or you can say this element. So the time complexity for this case is like very much time consuming. You can say order of n square, because we are using two loop. We are just iterating from one, like we are just comparing one character with other. So this number is compared with all of them. This number is compared with all of them. This number is compared with all of them. So it's like n squared operation. If suppose number is like they have given the input, they can go from 10 to the power 5. And if I say n square operation, which is like 10 to the power 10 operations will be performing in a two loop. Like the basic compiler or this Leetcode or any of the other compiler, it can maximum perform 10 to the power 7 operations, which is like if you see in general, it can perform one, like if you have heard about the CPU, they are like 1 gigahertz as a CPU. So it can perform only 1 gigahertz, or you can say 1 gigabyte of process. So it is like 10 to the power 7, you can say operations it can perform in a one cycle. So let's talk about that later. So we have seen like, okay, first approach is compare all the element with other element, which is n square operation. We need to reduce the time complexity. So the one step lower we can go, like we can from n square we can come to n log n. So the n log n approach is something related to sorting. What we can do, we can sort this array. We'll see, okay, approach 2. What approach 2? Just sort array. What we'll do after sorting array? So suppose array was 3, 4, 2, 2. After sorting, it will come like 1, 2, 2, and 3 and 4. So this is what sorted array. Now what we'll do, we'll compare again. See, here also we are comparing but with all the elements. In this case, what we will be doing, like we'll compare every element either with the previous one or the next one. So here I'll say, okay, 1, are you like equal to the next one? No. 2, are you equal to the next one? So in this case, okay, this is coming twice because we are just taking this number either with previous one or either with the next one. So this came twice, so this is a duplicate number. If we talk about the time complexity for this case, it is also order of like n log n, but still it's bit time consuming. So like very basic, we can compare all of them, or like after sorting, we can compare from previous or the next one. We'll talk about the, you can say the third approach. I'll talk for the third approach third, which is hash map. Hash map. What we are doing, like here, we will be placing or like storing counts or frequency of a number. So suppose this was our array 1, 3, 4, 2 and 2. What we want to do, we need to store all of them counts how many times they have occurred. So for this case, 1 came once. Well, I'll iterate over the array. I'll say, okay, 1, you came first time. Okay, your identity is 1. 3, you also come first. Okay, you take 1. I'll say 4, you also come once. Okay, take 1. 2, you came first time. Okay, take 1. Another time, this 2, again it will come and say, okay, already exists. Increase the count. So what we have created a hash map, or you can say a table-like structure having key and value, or you can say character and value, or the number and value. Number will be like 1, 2, 3, and 4. It have value 1, 2, 1, and 1. So in one pass, we have created the count, or you can say frequency of this array or the number. In another loop, what we'll do, we'll check, okay, which of the element have frequency more than once. So any element having frequency more than once will be a duplicate number. So I have created the frequency. Again, I'll check, okay, this number frequency is 1, this number frequency is 2. So this is the element having more than one frequency. This is a duplicate element. So for this case also, if I say time complexity is order of n, for like creating the hash map, order of n for like checking which element is coming twice. So or more than once you can say, because number can come more than 2 times, 3 times, or complete n times. So this is our time complexity, or if I say in general, overall time complexity, the order of n. But here we use the space, extra space we use to store for this count. If I say, if I show you in this question, they told don't use the extra space. Also, you need to do, you are not allowed to do modification in the existing array. So we need to find something else. We don't need to do comparison again and again. Like we are not allowed to do comparison with all elements. We are not allowed to store the frequency of element. So we have a third, or you can say fourth approach. I'll say this is approach fourth, which is like a bit extension of a linked list. So what we are trying to do, like we will be detecting a cycle. So I'll say like the approach one, you can say approach 4 is detect cycle. So what we are going to do here, if I in general I'll say this is approach 4. Okay, just 1 second. Okay, this is approach 4. We'll see detect cycle. C I detect CYC. Okay, fine. So we have an array. This was our array 1, 2, 1, 3, 4, 2, and 2. What we need to do? We need to detect the cycle. How we are going to detect cycle? Suppose in this case, just think it was a linked list. How? I'll say okay. There's one. If you just simply look, if I say like the index of this is 0, it's 1, 2, and so on, like 2, 3, and 4. In general, what they are trying to do, like they are, if you see, I in the first place, I talk like number can go from 1 to n. So at max, what they can have? They can have 1, 2, 3, and 4. You can say this was a number. So if I map it, like it will come to index 1, it will come to index 3, it can go to index 2, it can go to index 4. If we place this again to index 2, they will say, no, I already have 2. So this was a duplicate part. What we'll do, we'll create a cycle. You can say a linked list. How? We will be starting from this place. We'll say, okay, this is a number, go to the first index. Okay. So I'll say number 1. So I will start from number 1. Okay, this was a number 1 at 0th index. They told, okay, go to my index, place that number. Okay, number 3 placed. Number 3 told go to my index, place that number. I'll say okay, go to number 3, go to number 3 index, its number is 2. Now 2 say go to my index, place it. So number at here is 4. 4 say go to my index and place 2. 2 is already placed. If I say like it will go and again 4 will say go to 2. If I say this 4 told, if I remove bit more, okay, so here we have 2 and this was a array. So 4 told go to this, place 2. 2 told go to my index, place 4. So you can see this is now creating a cycle, and this is like going over all and all and all. So it will go like this. 2 say go to 4, 4 say go to 2, 4 say go to 2, 2 to say go to 4. So what we are doing, like we are creating a cycle. So instead of like creating that, I'll mark it like this. Okay, I'll take one more example. If I say like, you can say number 1, or I'll just take one example from here, like I already have or not. Okay, so I'll take example like 2, 6, 4, 1, 3, 1, 5. 2, or I'll mark the array. 2, 6, what was that other? 2, 6, 4, 1, 3, 1, 5. 2, 6, 4, 3, 1, 5, 1 something was there. Let's one more. 2, 6, 4, 1, 3, 1, 5. 2, 6, 4, 1, 3, 1, 5. Okay, so it is like 1, 3, 1, 5. Okay, so in this array, they told like, okay, this is the element coming twice, here and here. What we'll do, we'll again create a link. This is having index 0, 1, 2, 3, 4, 5, and 6. It started from 0, told go to my index, 4 told go to my index, 3 told go to my index, 1 told go to my index, he told go to my index, he told go to my index, and again now from here, 5 told go to 1, 6 told go to 6, and this cycle will go and on and on. So I'll again mark like it came to 2, 2 told go to 4, 4 told go to 3, 3 told go to 1, 1 told go to 6, 6 told go to 5, and 5 again told go to 1. So here what you see, like we have created one cycle. So there is a concept of slow and fast pointer in the linked list, like slow and fast pointer. If you have not watched last two series of questions, they are somewhat same, like using the slow and fast pointer. What we used to do, like we say, okay, slow go one step, fast go two step. Slow come here, fast come here. Slow come here, fast come here. Slow came here. Again, this came from here to here. So they meet at one point. We use two pointer. One is going one step. Another is going two step. So one came from here to here to here to here to here. Another one is going from here to here and again from here to here. So at this place, if I say like, okay, slow started from here, or if I say slow, slow was here, fast was here, slow came here, fast came here. Again, slow came here, fast goes here. At this point, slow came here and fast coming from here to here because it was placing two step. So this particular point, it collided. So what we need to find, like we need to detect at which point it is creating a cycle. So using two pointer, one is going two step, one is going one step, we can get at least, okay, there exists one cycle. So cycle means there should be at least one number coming twice. You can say this number came twice, which is creating a cycle. From here you are going here and later it is going here to here. Okay. So what we'll do, we'll use two pointer to find the cycle. Okay. Once we got the cycle, okay, suppose we got a cycle where our fast is also here, slow is also here. Now we need to find which particular position is creating that cycle. So what we can do, if you see something came here, will be like going on and on and on. Like it will go here, here, again come to here, go here, here, and again come to here because it was stuck in a cycle. If I say, okay, fast be there, I start slow from here, go one step. Slow come here, fast come here, fast come here, slow come here, fast goes here. Again, slow come here and fast come here. So what it means, like this is the place where again they are meeting. So one step we detected cycle and another step we detected the position where it started the cycle. So let's come to the coding part. Like by seeing the code, maybe you can get much idea what we are trying to say. So what we'll do, so startly we use like for detecting cycle, like we'll detect the cycle at which position it is starting from. So detecting cycle, and here like we'll start slow and fast pointer, and what we need to do, like we are just placing. So we'll iterate until they collide. So I'll say, okay, slow. Now come, okay, I'll show you once again. Like here, what we are saying, go start from here, place this slow as here. What we do for creating a cycle, we roll like, okay, start from here, go to the next index of this point. So what we are saying, okay, slow is started from here, it is going to the index value at that array. Okay, so we started slow as 0. We placed the number of value in 0. So num of 0 is 2. Slow started from 2. Num of this came to this because see, slow started from here. Fast will say, okay, I'll go to the value of this index. So slow was here, fast was here. What we do, I'll say in the code, slow, we say like, okay, you go to the nums value of slow, and fast we say go to nums of slow or fast. So just go to your index value first time, like go your index value here one by step, and fast say go to the index value of your index value. So here if you say it got 2 at first, they told no, go to index of 2. So it is now 4 of 2 is 4 for the first case. So okay, I'll told, okay, fine. What we'll do, we'll create this cycle, and at one place slow and fast will collide with each other. So I'll say at one place when slow and fast collided with each other, I'll break my loop. Okay, fine. This place we detected the cycle. Again, what we'll do, we need to find the start position where this you can say what the cycle started. So I'll say, okay, this is the index of, you can say, of the element which is creating the cycle. So I'll say, okay, slow again start from 0. What we'll do, again I'll loop till slow does not meet, or you can say once they meet, the loop will get exit. And what we'll say, again, go slow, go to your value at index, and fast this time will say, okay, go one step because it is now in a cycle. They are just moving around and around. So I'll say, okay, fast, just move one step. So go to nums of fast, and its nums. At last, both will be at same place. So like here you met at one place, here you will be meeting at one place and loop will get terminated. So what we'll do, okay, just we can return slow or fast from here. I'll say, okay, return slow. And this is what, like, we simply detected the cycle, we find the index, or you can say find the position where cycle started. So this is what this was our overall code, like its time complexity is order of n, the space we don't use. We have done in the same space. So just simply we'll submit and see it is working fine or not. So it's working fine and that's what we want to discuss. So yeah, thank you.